Okay, here's section 1.4 example 7, and possibly in the background you'll hear my dog snoring. Okay, so here they want us to find the reduced row echelon form of the following matrix over Z3. So notice nothing's bigger than 2 in here, 1, 0, 1, and 2, and hence they say solve this system. That's the corresponding system to this augmented matrix. And so I've put that augmented matrix into Sage. And again, first we need to tell it we're using Z3. So here I've said, okay, we're going to define Z3. Again, I use an R. And then when I make that matrix, I just remember to have to put that definition up ahead here so it knows what we're working with. And so then I have that augmented matrix that they gave me, and at that point I just do my reduced row echelon form and display the results. So I say evaluate, and here we have it, and that says my x is equal to 1 and my y plus 2z is equal to 2. And so I could subtract that from both sides and get a negative 2z. And let's look at theirs. So they go through, they get the row reduction, they tell us each of the items that they used, and they get to that same place. So they say there's reduced row echelon form, and they tell us, yep, indeed, x equals 1 right here, and then y equals 2 minus 2z. Now they change the minus 2z to a plus z. Again, they just use, what is negative 2? It's actually the negative of 2, the additive inverse of 2 is 1, and so they can change that to a plus 1 here. And again, if you're working in Z3, that's probably what you'd want to do. And then they say, well, okay, so z is arbitrary, but it can only be a finite number of things, 0, 1, and 2, and so they actually look at those 3 solutions by letting z equals 0, then 1, then 2. Notice x is always 1 because, well, it was set there up here. Whoops. Well, can't just get the first row, but x equals 1 here. And so it's always 1 in these, but then we see that y and z are changing depending on what z is. If z is 0, we get 2 for y. If z is 1, we get 0 for y, because 1 plus 2 is 3, but 3 mod 3 is 0. And then finally, if z is 2, well, 2 plus 2 is 4, and 4 mod 3 is 1, as a remainder of 1. And so there you go. So we can do that arithmetic, that reduced row echelon form over Z3 here without a problem in Sage. Okay, so that's example 7.